Here we're going to look at how to find the vertex of a quadratic function in standard form. So part A asked, what is the x-coordinate of the vertex of f of x equals ax squared plus bx plus c? So first we want to state that this right here is standard form. Okay, so ax squared plus bx plus c is standard form, and that's for a quadratic function. There are other standard forms. We are concerned with the standard form of a quadratic function for this section. All right, now the formula we're going to use is going to be x is equal to negative b over 2a. Sometimes you'll see that written as h equals negative b over 2a, and that's kind of a reference back to vertex form, which we've worked on in the past. Most of the explanations, I'm going to be using this x equals one. All right, but they are interchangeable. Sometimes you'll see the x equals, sometimes you'll see h equals. Don't worry about where this is derived from. Ultimately, it does come from vertex form and a combination of vertex and standard form and some substitution and manipulation of the equations. But just know that that's the formula. That's what we're going to use. So that's all for part A. You just want to be familiar with the formula. Part B is where we're actually going to figure out what is the vertex of the function, and we're given the function x squared minus 6x minus 10. So first thing we want to do is we want to label or state what a, b, and c are equal to. And we're going to reference back to our equation up here, right? The ax squared plus bx plus c. So if I rewrite this as ax squared plus bx plus c, I can see where these numbers come from. So a is equal to 1, right? We have a 1 here. It's not visible, but we understood that that's a 1. B is going to be equal to negative 6. Let's just clean that up. B is negative 6, and C is equal to negative 10. So if we were to highlight these, our A value is 1. Our B value is this negative 6 here, and our C value is negative 10. Now, you're not actually going to use the C value when you're looking for the vertex, but it will become useful in a later example. So what is the vertex of the function? Part 1 or step 1 would be to label A, B, and C, or define A, B, and C. Then we're going to use our formula. So we're going to take x is equal to negative b over 2a, and we're going to figure out what the x-coordinate for the vertex is. So we'll take our variables and substitute them. So b, we keep the negative from the formula, and then b, we labeled or defined as negative 6, and a is going to be equal to 1. And so a would be 1, and b we defined as negative 6. So now we simplify this. Negative negative 6, that gives us a positive 6. 2 times 1 is 2. Let's fix that. 2 times 1 is 2. And then we could reduce or divide here. So 6 divided by 2 would give us 3. So my x value is 3. And that would be my x-coordinate for my vertex. Now, for a vertex, we do need x and y. So what we can do is, remember that f of x is the equivalent of y. They're kind of interchangeable. So we're going to go back to our original equation, but this time we're going to say y equals x squared minus 6x minus 10. And we are going to replace our x value because we now know what x is. X is equal to 3. So y equals 3 squared minus 6 times 3 minus 10. I mention it quite frequently, but I always recommend using parentheses when substituting. So y equals 9 minus 18 minus 10. 9 minus 18 would be negative 9. And then negative 9 minus 10 is negative 19. So we now have our y value. So the vertex is going to be our x and y values. So vertex is going to be 3 and negative 19. And that will be our solution. So remember, you're just looking for x and y. To determine x, you'll use your formula. You'll take a and b, plug a and b in. A and b will help you find x. and then use x to substitute into your equation or your function, and that'll help you determine y. Once you have x and y, you have your vertex. That's it.